It's Algebra 1, lesson 6.3, solving compound inequalities. Part number 2, we're picking up on example number 3, says solving a compound inequality with OR. These are typically easier inequalities for students to solve than AND ones are. So if you were able to understand AND ones, this one should be pretty simple. Just solve them as two separate ones and graph them on the same number line. So 3x plus 1 is less than or equal to -2, or 7x minus 3 is greater than or equal to 18. You undo your order of operations backwards still. You still undo plus 1 by subtracting it for the first one. Do it on both sides. And you undo minus 3 by adding it to both sides for the second one. So minus 1 and minus 1, plus 3 and plus 3. Remember, anytime you're in an inequality, ask yourself the question, do I reverse the symbol or not? Do you reverse it with this first step? We added 1 for the first one, and we subtracted 1, and we added 3 for the second one. Do you reverse them? No, only when you multiply or divide by a negative number. So that leaves us with 3x is less than or equal to -3, or 7x is greater than or equal to 21. So for the first one, undo 3 times x by dividing by 3, and do it here. And for the second one, undo 7 times x by dividing by 7. Again, do you reverse the symbols or not? Yes or no? We're dividing, but it's by positive numbers for both cases. You may reverse the symbols for one and not the other on OR inequalities. That could happen. It usually won't happen, and I don't think it typically happens with AND inequalities because they have to face the same direction. So now it says x is less than or equal to -3 divided by 3 is -1, and x is greater than or equal to 21 divided by 7 is 3. So greater than or equal to 3. So this is a solved OR inequality. So the solution is all real numbers that are less than or equal to -1, or, that's key, that word or, greater than or equal to 3. You don't have to draw all of these numbers in between, everybody. Just show -1 and show 3, just like the other ones we were graphing. And they're both colored in bubbles since it says or equal to for them. Greater than 3 is to the right, less than -1 to the left. Okay, on the back, everybody, let's do this one. Solve this one, and I'm going to add to it at the end and graph it. Solve it and graph it. Remember, solve both of them separately, graph them both on the same number line. Real simple. All right, let's take a look at it. It says 6x minus 5 is less than 7. We want to get x all by itself. It's already on the left side. That's good. Undo minus 5 by adding 5. You do it to the left, do it to the right. Remember, when you add 5, 7 plus 5, you get positive 12. on inequalities, always see if you have to reverse your symbol or not. All we did was add 5 right there, so we do not have to reverse it. Now it says 6 times x. Undo that by dividing by 6. You do it to the left, do it to the right. 12 divided by 6 is 2. And remember, again, check yourself. Do I need to reverse the symbol or not based on the fact that I divided by a positive number? Only when it's by, it's right, only when it's by a negative number do you reverse it. So x is less than 2. Or the other inequality, we're trying to get x by itself. Again, at the end, subtract 1. When you do it there, do it here. 25 minus 1 is 24. So you have 8x minus 1 plus 1 canceled out. All we did was subtract 1. We do not reverse the symbol. It stays just like this. Then in order to get x by itself, divide by 8 since it's multiplying by 8. When you do it to the left, do it to the right. 24 divided by 8 is 3. And again, we divided, but it was by a positive number, so you do not reverse the symbol. The only other thing you have to do to consider solve this is just write the word or in the middle of those. This is a compound inequality with x is less than 2 or x is greater than 3. So we need the numbers 2 and we need the numbers 3 on our graph. You don't even need to show anything else. To show them in the right order. Make sure you don't have them in the wrong spot. So x is less than 2 is everything that way. You don't color it in because it doesn't say or equal to. And x is greater than 3. Everything that way. You don't color that one in, again, because it doesn't say or equal to. Example number 4 is having to reverse both inequality symbols. So negative 7 is less than negative 2x plus 1 and less than negative 3. So this is an and inequality because x is in the middle of two symbols. Again, notice that the symbols go the same direction. They both say less than. One just has or equal to attached to it. The first thing you want to do in the middle, just like on the ones we were doing yesterday, is undo plus 1 by subtracting it. When you do it there, do it here and here. Negative 7 minus 1 is going to give us negative 8. Negative 3 minus 1 is going to be negative 4. Do you reverse the symbol? No, all we did was subtract. Leave the symbol alone. Negative 8 is less than negative 2x, which is less than or equal to negative 4. Then undo negative 2 times x by dividing by negative 2. If you do it there, do it here and here. So negative 8 divided by negative 2, we know a negative divided by negative is a positive, and it's 4. And negative 4 divided by negative 2, again, a negative divided by negative is a positive, and it's 2. Do you reverse the symbol? Yes, we divided by a negative value. Therefore, you reverse both of those symbols. Less than becomes greater than 4. And less than or equal to becomes greater than or equal to positive 2. So divide each expression by negative 2 and reverse both inequality symbols. Therefore, your solution, and notice right here, this is the exact same thing as this. Just notice it's written backwards just to put the smaller number up front. But the big mouth of the inequality is still eating the bigger number in each occasion. The solution is all real numbers that are greater than or equal to 2 and less than 4. That is just writing a sentence or writing words. We did that on the bell word. And then graphing it, remember, with an and inequality, you're going to have an overlapped area. And again, you don't have to include everything except 2 and 4, everybody. You don't need everything else. 2 and 4. X is less than 4, so this way, open bubble, everything this way. X is greater than or equal to, close the bubble, everything that way. That's how the graph should look with the overlapping area between 2 and 4. And then on the side of that back right there, one more time, let's solve this one. And again, I want to add on that graph it. Remember, you're following your order of operations in reverse, just like equations. Undo -1 in the middle by adding 1. If you add it there, add it to the left and the right. Add it to all three portions. -3 plus 1, -2. This cancels this. -2x is still in the middle. Don't lose the negative. 5 plus 1 is 6. Do you reverse the symbols or not? No, all we did was add 1. Leave the symbols alone. Less than stays. Less than or equal to stays. Divide by -2 to cancel out -2 times. Do it there, do it here, and here on all three portions. Negative divided by negative is a +1. 6 divided by -2 is a -3. Reverse them or leave them. Reverse them. We divide it by a negative. Less than becomes greater than. Less than or equal to becomes greater than or equal to. Solved compound and inequality. X is greater than or equal to -3. So we need to show the numbers -3 and 1. Greater than or equal to -3. Color the bubble in. Greater than goes that way. Again, if you have to reorder this portion where you can see it, put X first, put 1 second. The big mouth eats the big number 1. X is less than, don't color the bubble in, 1. That's what the graph should look like there. Checkpoint. -25 is less than or equal to 11x minus 3. Undo -3 by adding 3. When you do it there, do it here and here. -25 plus 3, -22, is less than or equal to 11x is less than 11. The only thing different from this one compared to the other ones I was doing, I just didn't draw the lines going down. Draw them if you need them. And I didn't ask y'all midway, do we need to reverse the symbols or not? All we did was added 3. Divide by 11 for the next one to get x by itself. That leaves you with x. Divide this one and this one by 11. -22 divided by -11 is -2. And 11 divided by 11 is 1. Reverse them or not? No. Divided by positive, you leave them just like they are. Less than or equal to is less than. This is a solved compound and inequality. Okay. When you graph it on the number line, include only the numbers you need, -2 and 1. Okay, if there's a number line already drawn for you with a bunch of tick marks and all, that's fine, use it. But if you have to draw one, don't waste time putting all those little marks in. This one's easy. X is less than 1. Open bubble, everything that way. This is the one you might want to reorder. Put X first, -2 second. The big mouth eats the X. Greater than or equal to, color the bubble in this time, -2. Or inequalities are typically easier for students to do. Solve this one. Undo -5 by adding 5 to both sides. -9x. All we did was add, leave the symbol alone. 13 plus 5 is 18. Divide by -9. Do it here. Positive 18 divided by -9 is -2. Reverse it or leave it. Good. Divided by negative value means reverse it. X is less than -2. This one we're going to do the same thing. Add 1. 2x is greater than or equal to 4. Again, we didn't reverse it there because all we did was added 1. Then divide by 2. Do it here. 4 divided by 2 is 2. Reverse this one or leave it. Leave it. All we did was divide, but by a positive number greater than or equal to. This is an or inequality, so or goes right in the middle of them. X is less than -2, or X is greater than or equal to +2. -2 and +2. Less than -2, open bubble. Greater than or equal to, close bubble, 2. Everything to the right.